Hi guys, welcome to my channel. This is Steve again, back with another Atari video for the YouTube. This video, what I'm going to actually do is I'm going to concentrate on showing people, first of all, how the Max 65, which I have here set up in the background, kind of works and stuff like that, and kind of go through a program that I've been working on. It's a game. There's one I have on my YouTube channel. It's actually called Dead Man, and I've actually modified it. I can run it here and show it to you in a little bit. Added some new stuff into it, like ability to jump and stuff like that. Nowhere near finished or anything, just kind of a sketch or a mock-up, if you will. I just wanted to expand on this for anybody who actually owns the Max 65 cartridge, which actually I've showed it a few times here, but it's here in the background, which I know you're not going to be able to see. It's too dark around here. But it just plugs into your computer, basically. I got mine on an internet website one time. Somebody was advertising it, and I asked them if I could buy it, and I bought it. I paid a pretty good price for it, about 65 bucks, and it's been worth every dime. I mean, it's just an amazing tool. You can do so much when you really start learning machine language and stuff like that, as I've taught on my videos. So let's get started. I'm going to kind of list this and just kind of show you the whole program, so people who really want to see the whole thing, I think that'd be fair to do that first. Give me 1 second. Oops. Well, actually, forgot. I wanted to demonstrate before I loaded this. This is actually the Max 65 load command. Unlike Basic, where you actually use the semicolons, you don't use them in the machine Max 65. You just basically load number D, semicolon, and D, whatever the name of your file is going to be, the extension, and then whatever you call it. Usually Max 65 is M65, Basic is BAS and stuff like that. So let me load this up. Okay, the disk drive's whirling over there. It'll take a few seconds here. I'm using that 1040 disk drive too, by the way. I mean, they've made so many different disk drives out there, but let's see here. Okay. So maybe I'll go this a little slow, and if I scroll through it super fast, people are like, I can't see it. What you're looking at here, actually, these are actually the label names that are going to be set up in the program, or the variable names that actually refer to the hexadecimal addresses. I demonstrated this in videos before, where you can take this hexadecimal and you can convert it into a decimal. These codes right here, I've actually showed this a few different times, but they're actually in this book, the mapping the Atari mapping the Atari, and you can actually go through the book here, and you can see, like for example, if we looked up, let me find one that's actually in decimal here. I'm not very good at reading hexadecimal. Here's a good one. HPOS M0 53252. You just go to the page here, and it lists them directly by address. So if you go to 53252, which I have mine on page, let's step back here a little bit, page 112. And if you look up there real close, it'll take a second for this thing to focus. It's right there, 53252. It's the horizontal position of missile 0. So I have this set up in my program so I can detect collisions and stuff like that, which I'm still working on. So they're not pretty much, well, they're not polished yet. It's still in process. So as I go through this, you see that you would set those all up like at the beginning. These are actually another way to set up your own individual variables. You just put a .ds after it. And sometimes you can do a .byte, like this one I did, a .byte 0, and you can call it whatever. You know, this is just basically how you set them up in the Max 65 cartridge. Here we actually get into some of the assembly code here. And like I said, I'm not going to try to digest this entire thing, because it would probably take a long video to go through it, but I've showed this in one of my videos before. This is actually a delay loop. And these are some of the ways that you would set up a draw to within Max 65. There's actually a draw to command that's actually being executed by another program, because I have this combined it with two different files. So I'd have to load up the second one to show you that. But these are actually how you draw the level and stuff like that. And this is actually reading the screen coordinates, so it's basically reading, like you saw earlier, those variables, which actually has a bunch of data into it, and it's reading it into the screen. And I know this is making sense to people until they see what's really going on. This is actually a little bit more sophisticated for people who really want to understand how to produce numbers in assembly. you actually have to convert them down, and you have to break them down by their bit codes. And don't even ask me to explain it because it's pretty complicated. But I got this program from an Atari magazine I had before, and it outputs the numbers into this the columns. So you would have like if you remember back in basic or back in elementary school where you had your numbers set up and you had the firsts, the tens, the 100s, the 1000s, and so on. You do the same thing in assembly. You have to break the number down bit by bit. So it's pretty complicated. I just noticed this threw in some error message if I go to run this. Well, it's commented out, but I think it's overflowing the buffer or something. Okay, so this is the binary conversion of the number to get it to the screen so that you can see it. If you don't convert it through binary, it's going to look kind of funny, like a bunch of garbage. I'm trying to see what this is. I think this is my, oh yeah, this is my redefining. This is pretty interesting. These are my VBI routines. Let me go back here a second. Let's see, I think these are 2700. And here's how you list in assembly. You just type the number, comma, whatever. Yeah, that's right. Back a little further. Maybe 2600. Okay, it's right here. I just wanted to show you from the very beginning. This is the VBI label I have set up. And this is whenever you're setting up a vertical blank interrupt, you always want to make sure you push to the accumulator, the value that's there, and you want to transfer X to the accumulator, since we're going to be using X down here. And then you would do it on a push after. That's the basic setup for a VBI. And then this actually gets into the VBI here. This is just some code I have. This actually, if you've seen my Deadman video online, this is actually the river animation. It's going through a character set here, and it's shifting the bit, and it's reading it back here into the, how many output it's reading in, sorry, 24, which is the number of characters I have in that character set. I wanted to go into more explanation too, so this video might be a tad long, so kind of bear with me. But people are, they're interested. Some people have actually just bought the Atari. One guy said he bought one this year and he was interested in learning basic programming. So thank you for and welcome to the video here. So what I wanted to show you is a basic setup for a character set. I'm going to hold this book up in the kind of, if you really want to know, I can show you which book this is in general. I got this online. It's called the Compute's First Book of Atari Graphics. I want to lose my page here, but it's a pretty cool book. It's got a lot of games in it, basic games. It's a good book for starting up. It's one of the ones I first learned other than the original owner's manual. And if you want to see the owner's manual, this is the owner's manual for the Atari. So what this is right here, I have this on whatever page this is, I don't know, page 54. This is redefining a character set now. Look real carefully at this. Okay, this is actually a graph broken down into 8 by 8 dots. That's 8 rows in length and 8 rows in height. What you're looking at, the numbers at the top there, and I know it's kind of backward here, it actually, you would write it from left to right. But you would write 128, 64, actually, you know what, I forget, this camera reverses everything, so that's correct. 128, 64, 32, 16, 8, 4, 2, 1. Those are the binary representations for the character set. And what you do is you see the little, this is the number 4 that they have built up here. You see in the center there, or we should say stop shaking. You see in the center where it's got the number 4. Look carefully beside it on the row right here. I'm going to point here for a minute. Now look at the book here. See right here where it says the top part of the 4 here. Look at those numbers. You see 8 and 4. To get that calculated, you would add 8 plus 4, which is excuse me, it's 12. So you would actually write 12 in the first column beside it here. And then the next one down, you would actually add 16 plus 8 plus 4, and then calculate that, and then you would add 64 plus 32 plus 16 plus 8 plus 4. And that's how you do the calculations within binary. And what you may not even know as you're doing this, you're actually learning to count in binary. Because the binary number, for example, let's use the first one, which was 12. The binary number is actually 0. Let me look at the book here because I know I'm going to do it backwards. It's actually 0, 0, 0, 0, 1, 1, 0, 0. So wherever you see those little bits filled in there, those would be the ones for binary. But that's basically what you're looking at, and that's how you build a character set. So I'm going to kind of show you on paper how I do it. I just use graph paper, and these are some of the designs I came up with. I'm actually working with a friend right now, and I'm going to get an animation editor so I can do this live myself and a little bit faster. So I have to draw everything on graph paper here, which isn't coming out good at all. But you see there, that's how you you build them yourself, and you just use graph paper. It works really well. And look, this is a great example because you can see my numbers here beside it. If you look at this funny man here, where's he at? He's right here. Is he this one? He's this one right here. You see these numbers right here? Oh boy, try to do this backwards. See 24, 24. If you look over here, right here where the head is, that's 16 plus 8, so that equals 24. And then here 16 plus 8 equals 24, and this one only has 8 in it. And then you go over to the number and it's 8, and so forth and so forth and so forth. That's how you build the characters to get them to look like on the screen. And those are actually for redefining characters, and you can also do player missile graphics that way as well. So what I'm going to do is I'm going to actually go ahead and run this game, and I'll come right back to this in a minute. I know I'm kind of jumping around here, but I think people might want to see this instead of just hear me rambling on about it. So let me run it once here. Now to run a program in an assembly or in the Mac65 cartridge, you would just type ASM, hit enter, or enter, return. We use say enter now, but they have return key then. And wait for it to compile. Now I have my optics shut off, so you won't be able to see the screen regenerating the program. Usually it'll list all the code unless you use the opt.obj no list, which is actually right here, opt.obj, and it'll say no list. That'll cut off all the code from being displayed, because you don't want to show the whole code while it's assembling, because it takes forever. It's got to go through the whole code and then it assembles the program, so it's faster that way. Okay, so I have no errors, and it just kind of tells you the bytes per unit. Then you just run it like with the DDT editor. And I showed this one on many videos. You just set the hexadecimal address. I have this at location for the counter of 8,000. And then you just type G asterisk. I'm grabbing my joystick here. No, actually, let me run this. Didn't come out right. Gotta work on it. There's a bug in that. Okay, so this is kind of where I got it so far. This was the original Deadman. I just kind of modified it a little bit here. Let me see if I can move this down more this way. That's a little bit better. The TV. That looks kind of straight that way, huh? Okay, so what I got here, I just unplugged my joystick and plug it back in. Okay, so down here is my little character here. I can move at the bottom, and if I press my button here, oh, you know what? I turned this off earlier, but he was jumping. I got to turn it back on real quick. Let me just go back here real quick. I have to teach you something else. This is actually, if you go to the end of this first listing here, gosh, I think it's at 6800, and this is the end of the first listing here. You see this at the bottom where it says include number D dm2.m65. That's how you load and append in a second file, which will be appended at the end down here. So I'm going to load that in real quick here. And that's just so we can fix that jumping ability, because earlier he wasn't jumping very good. But I had worked on this actually for 2 days trying to figure out how to get a good jump. This didn't want to work right. If I pressed the button, it kind of only showed him jumping up a few pixels. Okay, so the line that it's actually occurring at is at, I gotta remember, it's 1900. Oops. Did it load it? No, that was 1900. 1900. There we go. So 1900. This is the line called descend. This actually allows the character to drop down. So earlier what I did is I turned this, I think I turned it off. Let me see. I did something to it. Maybe I didn't turn it off. Let's see where I did it at. Jump range. Oh, it's down here. Oh no, I got it on here. Okay, let's see. 1500. I'll kind of play with this a little bit. I think what I did is I added something new in here. I added the missile in there. This ball. I'm going to comment this out for now. So what he's doing is I have him, if you press the button here, he's going to jump up and everything. And this program is going to set gravity. So if you're not pressing the button, it's supposed to fall. And that's what this is trying to do right now. So I'm trying to see what I did here. Jump range. This is checking for a value that you jump. Every time you jump, it's going to increment this value. and this one is actually decreasing it since he's falling back down, so it's decreasing it to see if its branch is not equal to 0, then we want to continue falling, otherwise we're going to reset the jump range. So, I'm going to see what I did to change this program. Go back here again. So make sure I haven't missed any. I think it was the joystick. I know what I did. The joystick. I took out the joystick. That's it, right here. This is the joystick on this line. I just need to add this back in so I can fix this correctly. Yeah, save this. Always make sure you save. You probably heard that in any computer programming, any kind of computer file project. Always save because your data is always guaranteed. And my video is getting kind of a little bit crooked again here. The camera sits on a funny angle. Makes it look crooked. That doesn't look much better, does it? Okay, so it's going to take a second to save this. Excuse me for that. Maybe keep you occupied with something else, I don't know. Shouldn't take too much longer. That's one thing about the Atari disk drive, they could be really slow. Trying to hammer out those sectors. Okay, so we're going to load in the first one now that we've got this saved. I'm going to assemble it right away. And run it again. You know what I'm going to do? I'm going to run this code here while this is loading and save some time to explain back off on the VDI where I was at earlier here. Where did I stick it at? 231. Here's another utility you might see me doing in the past. I don't know if I demonstrated. This is called the find utility for the Mac 65. You just type find and then you put a little slash in there, the name of the word you're looking for. In this one I was searching for VDI. You put the line number that it's going to start at, and you're going to put the line it's going to end at. 655.35 is the maximum number of lines in the assembly program. So I'm going to change this since I'm searching down next level there. So right there it is, 2600. Okay, here we go. So what I'm going to do is I'm going to load this up, I'll hold this up full screen because I went over this earlier, I went over this. I think I kind of left off right here. I'm going to leave some room down here. It's going to take erase some screen lines, so I'm going to kind of put it up here while it's assembling. Okay, so back on this line, right after we've set up the VDI routine, what this is doing here is this is actually clearing out the player missiles, and this is actually going to, this one I'm not using actually, this is commented out, this is commented out. This is setting up a direction I have, because you'll see that this ball, or you might have noticed that ball that was moving on the screen there, it goes from screen to screen, and I'm making it say which direction has it hit. Has it hit this side? If it has, it's going to flip this. If it's gone here, it's going to flip that. Like I said, I know this isn't going to make sense to anybody. But this jumps out of the loop for the VDI. If you exit out, I'll show you later how it's done. Let me run this now. Sure you want to see the game. Okay, now you see me when I'm pressing the button, he's jumping. So he's doing jump and everything. I don't have it fixed, so if you jump here, it won't let you. You know, it kind of hits the wall and it gets stuck there, so I need to work on that still. But you see how he can just jump freely and stuff like that. So earlier he couldn't do anything except move to side, but now I got him kind of jumping. And this ball I was showing you earlier, this is where it's following the direction. Notice as it goes off the screen, it'll come down to the next level, and it'll repeat back, and it'll come down to the next level, repeat back, and come down to the next level, and it'll cycle back up here again. So watch it for a second. I don't know, it looks like a box on here when I'm looking at the screen because it's going so it looks kind of funny looking. But this is kind of where I got it in my program so far. You got the ability of the player moving around here. You can't go up the ladders yet, I hadn't programmed that in, but so I'm working on some kind of a platform here, I guess you could call it. And see, notice how fast this is in assembly. I mean, if you see my basic programs, this thing is moving pretty fast. And I even have a delay set in this, So it's actually slowing down the player here as he moves. But what I was showing you earlier, I hope this is going to work and not crash. I'm going to try to show you the score counter here, which I was demonstrating the numbers earlier. I have it set up on the option key, but I hope it doesn't crash. There it goes. You see that change in there at the top? If you look up here, the numbers, you probably can't see them, but they're changing. And these are side by side, so this is the ones, that's what it is, the ones, tens, hundreds, thousands place. That's how you set them up in the binary coded way. You have to lay them up exactly side by side that way to calculate them. And then just hit the option key and it just puts a score in there, kind of increases it. So later I'm going to have a score, I'm going to have a level, and a min counter, and whatever else I'll need into it. So that's kind of where it is so far. If I could get this in any better, it looks kind of bright over here. And I can never control how bright it is, but anyway. Let's go back to the code. I'm sure you want to see that now. We got on 2600. Okay, so down here, these this direction's going to make a little bit more sense once I go into explaining that. So I'll try not to explain everything step by step, because this is going to be very long and tedious to try to go through all this to people. But basically what this is doing here, this is actually keeping track of your player's position as he's moving across the screen. Let me just double check that. Oh no, you know, I'm sorry, this is the ball that's moving on the screen. So this is the location of where it's going to be set at, which is at X1. Decrement X1 means to calculate it backwards, so if it's at 100, it's going to be 99, 98, 97, so that keeps it moving. If you see it moving this way, it's decrementing, so it's moving in that direction to the left. And here it's going to see, at that location, after we've been moving, that ball hasn't hit location 15. Keep in mind your screen is made up of a bunch of resolution and pixels, side by side or numbered, invisibly, you can't see them. If you think of the graph that I was showing you earlier, with all the dots on it, it's the same thing on your computer screen. So side by side there, how it works out. Looking at this video, it's already 22 minutes. And this is basically what it does. It says once you've reached position 15, BCC means branch query clear. If the branch query is clear, in other words, you've reached 15 or less, then it's going to go to this label I called RGT, which is actually a short-term notation for reverse to the right. So in other words, if it's going to the left, it's going to reverse back to the right. So, and if it's not hitting, if it's not here already, then it's going to jump out of the loop, which I was showing you earlier. If you jump out of the BBI, it's just going to continue on with where it left off at. So let's see, reverse right. Wanted to try to keep this in order to show you where is the reverse right. It's probably down here. This is just flipping him to the left. It's the same thing, except if he's at 235 position over here on the screen, X1 means branch query set. So the branch query is set, and he's at 235 or greater than 235, then it's going to reverse him to the left and do the opposite. So that's what gets him moving around like that. Down here is the one we're going to come to in a minute. Let's see here. This is resetting the ball's location. I remember what this is doing exactly. It's setting up the... No, I think it's the positions of the screen. I don't know. But anyways, let's go down here where I wanted to stay consistent with this. So we're reversing to the right. Remember earlier when it was comparing to see if its branch query clears all the way over here? If it is, it's going to go to this next position. Next, might call it a function or whatever you would call it in assembly. It's going to this label, and it's going to increment a new variable I've actually named ENMYPOS, which stands for enemy position. So basically this is saying, where is that ball at right now? So it's just keeping track of the ball to figure out where it's at. So every time it hits over here, it's going to be a 1. Enemy position will be a 1. If it hits down here, and the next is going to be a 2, 3, and this is how I was able to track where it was at on the screen. And then what this is doing is adding, this is another thing, this is I might have showed this before. If you want to check out my Google page I have for the Atari assembly, I'll teach you a little bit more about the calculations. What this is doing is it's adding 15 to the value in the position of Y, which is that character moving on the screen. Once you've added a number to it, it's going to add what's already in there. So if the character, let's say he's at line 160, he's at position 160, you're just going to add 15 to that, which is, what was that, 175. So that would move him down the screen, and that's how you see the ball appearing down here. This line here is erasing the ball. If you don't erase it, it's going to leave garbage on the screen. this right here, let's see, make a new G. Oh, this is actually just redrawing the ball down on the new position. Because if you're erasing it, you're not going to see it, you have to redraw it. And this one right here is the directions I was telling you about. So basically it's saying, once you've gone all the way over here to the right, excuse me, all the way over to the right, remember this is 1 for DIR. When you hit over here, it'll be stored, it'll have a 1 in direction, this is what the DR stands for, direction. Then it's over here, because remember it's moving to the right, this one's moving to the right. So as soon as you're over here, direction will suddenly become a 2. And again, that's how I'm keeping track of where it's moving on the screen. So when it gets down here, I think it's like 5 or something, and it fits back up here to the top. That took some work to get that thing working. So let's see here. This one does the same thing, except it's the left position, and it's keeping track of, I don't know, oh yeah, this is redrawn, clearing the bad guy, enemy position, just storing it back in a 1 again when he's over at the left side. That's what I was talking about earlier. This is what I showed you a few different times. When you're not doing anything, the conditions not being met, you want to jump out of the VDI, and to jump out of it, you would pull from the accumulator. I think this one is transfer X into the accumulator. I might have that backward. And this is pull, and then you would jump to this location, which jumps you out of the VDI. So down here is, not to explain it fully, but this is how you clear the bad guy. And kind of go into an explanation of this is a high and low byte. If you watch my other video where I demonstrated the low screen locations of 88 and 89, this actually is the same thing, except it's actually just locating where that character is on the screen instead of the high and low byte to clear it out. So, well, like I said, I feel like I should probably go and explain this entire thing, because I mean, first of all, I don't have anywhere you can download the program to an emulator or anything like that, so that wouldn't be fair for people. I just wanted to kind of give you an upstart on how assembly is. If you're ready to tackle this, it is pretty tedious. It is something you're really going to have to stay with, because when you're assembling and when you make mistakes in assembly, it's a lot harder to find them than it is in BASIC. In BASIC, if something doesn't calculate, you can throw in print this variable value and see what's going on. In assembly, you can't really do that unless you're outputting those numbers to the screen in binary code format. So it's a lot more complicated. At least I haven't learned how to use the debugger to do that correctly yet. So what I do is I just track where the program is and what I think is going on, and kind of guess at things a lot. Sometimes I have to really go in there and try to say maybe it's in this line, and if it is, then I can set up a break in this line or something like that. So, and that is one way to output them. If you break them, you can see the values in assembly in DDT. But anyways, this is just drawing the guy. This is something I haven't put in yet, but I'm getting ready to animate my characters as they're moving. Like, so I'm working on the animation stuff still. This is all the frames of the animation. 1, 2. Here's something else I was going to add, but I didn't implement it all the way. This is the ball's velocity. Trying to see, I was going to try to make a bouncing ball on the screen. Maybe I'll add that in later, but just decided not to do it right now. I think it'd be kind of cool. Keystone Capers for the Atari 2600 used to have a little bouncing, I think it was a bouncing beach ball or something, I don't remember. Some kind of bouncing ball. And I'm trying to see what this one does. I think this is another clear here. This is just for the ball, but this is drawing the velocity of the ball up. This is how I was going to have it. If it's moving up, it's drawing the ball as it's moving up, and that's basically all that is. This is a wait, another wait delay in assembly. These are interesting down here. This is what I was talking about in another video in my display list interrupts. The display list video that I put up recently. I was telling you I was going to do another demo, except maybe on display list interrupts. That's exactly what this is. It's called a display list interrupt. And what it allows you to do is it allows you to interrupt the clock cycles as the computer's going through something, stop it, and make things happen during processing time. So what this is actually doing, when I ran the program again, and let me resymbol that just to show you. Actually, I don't have the symbol for it, so I'll just DDT. That's another nice thing about this. You just go right in once you got it in memory and just go back to it. So if you look here, you probably can't see it real well, but this is like in green, this is in orange, this is in pink, and this is in blue down here. And this is in gray up here. Normally in a graphics 1 screen like this, in BASIC, you can be limited to the colors you can display. Now this is an antic mode I'm using, so it allows more colors to show up side by side, but even still, with BASIC and assembly, if you're not using the display list interrupt, you're going to be limited on your colors. Look, notice my ladder here has you probably can't see it, but it's a bunch of individual colors on it, and these down here have individual colors. That's what's nice about this displayless interrupts, is you can go right down the screen and start changing those scan lines as they're changing. You can control the colors in them. And I did this in another video, but I don't have it in this one, where I can control the colors of my player and all kinds of stuff like that. But that's what I wanted to show you. This displayless interrupt is basically doing in this. So I hope I didn't forget which line I was on. Let's go back here. Right after the DVI, I totally forgot where I was at here. 1 second, it's down here. So, right, 4700. Okay, so what this is doing, and this is actually keeping track of the color location. So 53270, I'm going to look that up in the book here since I don't have that one memorized. My map in the Atari book again. 53270, right here. So that came out pretty fast. You see right there it says color and luminance of player field 0, and beside it it says 708. That's basically changing the colors of those pictures that you saw on the screen. Like I have the little walls showing up, and not the ball and not the player, because those are actually player missile graphics, which is probably another video I need to explain. Allows you to set up your own individual graphics separate from the screen graphics. But these are like the screen and things you plot on the screen. If you watch my first simple game video, actually not that one, the second one where it's called Atari Game Design, I think that's the one. Basically in that I showed how to redefine characters, and I showed all those characters on the screen for the maze. That's what these are doing, is these are allowing you to change in the color of what you want to strike within those characters. So if you have a wall here and you have it in one color, as you're scanning down the lines here, you can change the colors in between it and stuff like that. It's some pretty cool effects on the Atari. So that's what this is basically doing here. This is just a loop to stay within the displayless interrupt. So it's called decrementing the X register, because notice up here you set it at 170. As you're decrementing, that means it's going down, it's backward. You want to compare the X register. Anytime you use an X, always follow with the appropriate comparison. And I'm checking to see if it's at 20th scan line. And if it's not, it's going to keep doing this loop, so it's going to allow those colors to cycle down the screen. But once it reaches the bottom here, it's going to reset the individual value I set up for my DLI colors. And I use this as a mapping coordination, so I know where to hit the plots at on screen. It's pretty complicated stuff, but it's interesting. And this is just how, again, you exit. Very similar to the BVI. You transfer, actually accumulate, pull, except you use a return from inner. It's called an RTI. That's the label name here. But you basically use that to exit from the loop. And here's one I have here for DLI2. This one does not work, so I'm not going to explain this one. This right here is kind of the start of the program. This actually this initializes the graphics. This is a special subroutine that's set up. I got this from another book that I had before that is called Atari Assembly Language or something like that. Allows you to set up graphics 0. This is actually being set up here for the character set. So basically it's initializing the character set, setting the top of the memory, and this is just subtracting 8 from the top of the memory so that you don't overwrite any other data like player missile graphics or something like that. And not to go into too much explanation, because I'm sure this is going to make a lot of sense to the people. Down here, I'm turning off the cursor. This is the cursor location. This is controlling my levels to see which levels I think this is, I'm sorry, this is the level number counter. You saw where it said level up here when I ran the game. This is going to tell me which level I'm on and set the location of the numbers for that. And this set in locations of the score, which I showed you earlier, is in the 10s, 100s, 1000, 1s, 10s, and 100s place. So 1s, 10s, 100s place. And this right here is just how you set up, this is important, this is how you initialize a BVI. So once you've set it up there at the top, you would use load the Y register, and you set the number, and I think this is the low byte. It might be the high and the low, I forget which is which of these. But you set the high and the low addresses of the BVI to find out where it's being stored. In here, the computer's going to track where this address is at by looking for that label name and putting it in there. And then you set it to 7. This is how you initialize BVI. You always use 7. And then you just JSR 2, the set routine. This is actually, I have this up here at the top here. Let's set VBV. Let me see if I can find this in the book. I guess like 54 something. But that's basically how you initialize it. I looked it up in the back here, probably faster. Set VBV. Well, it sets the vertical blank interrupt. I think it's 58460 or something like that. Anyways, this is how I set it up here, and I had this on, but I turned this off originally. This is actually, I just turned on the up and down player movement, so you don't want the player to be able to move on the screen, but if I ever need a testing, I can instantly turn them on so I can move them up and down. Just some kind of tricks I've done in this. This is going to be a little more complicated, but this is actually setting up, let's see here. Well, this is setting up my display list in general. This is just initializing it. If you look in my other video where I show the DL equals peak 560 plus 561 times 256, that's what this is doing, is it's calculating where the display list is set at, and it's storing the high and the low byte in the addresses. I think it's 203 and 204, so it's storing it there. And this right here is just controlling the high and the low addressing of where I'm going to control those scan lines as they're moving down the screen, so I can change the display list as it goes through. And I said this one's going to be pretty complicated. I'm trying to get questions like, what was that? But anyways, assembly, like I said, it's not for the beginner. I don't recommend going to assembly. I recommend learning basic first. So let's see, this is just a more display list. Here's how I set up the very similar to the BVIs. So I just shut off the TV here. Give me 1 second here. The power button is like right here, and I just pressed it with my hand accidentally. So I'm going to turn this thing back on real quick. I'm going to call this one a timeout, huh? This thing takes forever. This is one of these Dynex TVs. Okay, here we go. So I'm going to leave that so I don't mess with that anymore. So anyways, where I left off here, this is the display list interrupts. Set a high and a low byte for the addressing, and then store it. This is how you initialize a display list interrupt. You have to use like 192 and store it into the variable of NMN, and again these variables are found in that map in the Atari book. You can use the number too, but I just usually use the labels to figure out what it's doing. This is setting up where my Y is going to first start. This is my character position. I'm going to have him at 120. And then right here, oh, the X register, he's going to be at 120. 46. So basically he's going to be over, did I get that right? Let's see, no, I'm sorry, he's going to be over 120, and he's going to be, I'm going to have him start down at 5. I think that was just so I could clear the screen. But anyways, going down here, this is pretty long here, but this is how you initialize a character set. Oh, I'm sorry, no, I showed that earlier. This is actually, why this all commented out, so let me just move on. It's right down here, I think. Let me see. No. Actually, this is clearing out the player missile graphics on the screen. So remember, when I showed you this earlier, these characters, you can make a player missile graphic that looks something like that, like my character on the screen. And this is just going to allow you to clear out those players in machine assembly language here. Again, storing the high and the low byte into the address to clear out the appropriate place in memory. What's down here? Well, this is just more initialization of a player. This is just setting up general specs, like you have your color, this is your position of your, this is the ball's position, by the way. More color, and I think this one is a collision. Let's see, enable player missile graphics, so this is how you enable one. And let me pull the second one up here. It's pretty much done. So how you guys doing? You keeping up with this? I know it can be quite a handful, huh? Okay, so we're into the second one here. And this is, again, from that include file, so this is including in the second file here. And what this is doing here, this is leaving off where the letter screen left off here. So I think this is just inserting the player, let's see, player byte put in place for the next byte. Yeah, this is just drawing my player the first time he appears on the screen. You have to draw him. If you don't draw him on the screen, he won't show up until you make him appear somewhere. So this is drawing him on the screen. And I kind of went over all this earlier, but I had this commented out. I was just moving code around here, so let's skip down here a little bit. These are colors again, 708, 709. Showed you that earlier. And this right here, this is what I was showing you about the enemy position earlier, where that ball is moving at, and I just set it to 0 when I first initialize it. This is one I didn't show you yet. I can probably go into any more detail. This is when you saw him jumping on the screen earlier. This is just zeroing out that jump location so that I can keep track of how far he's jumped. And this one right here is making the player, and this one is building. I think I was going to have like a third player in, but I didn't get him in there yet. Okay, so this one right here is, if you ever paid attention to the Atari 2600, or if you let the Atari on for probably, I think it's about 2 or 3 minutes, it starts changing colors. This turns it off from the colors changing on the screen. You just set that in your program. You can do that in Basic too. And this is actually, right here, this is checking for my console keys. On the side of the Atari, you'll notice there's a start option. What is it? Start option select and help. This is actually checking to see if you press the start key. I don't have this implemented correctly, but this is supposed to print numbers. And I have the option set up to print. Earlier when I was showing you those numbers and I was changing the score, this is what this is doing. It's allowing me to control the option key so I can change the numbers. This is an output until I find out what I want to do with them later. This is reading the joystick. That's what this means, RD stick. This is when you saw me comment this out earlier and I put it back in. What this is doing, and I'm still working on to get this fixed, is when you press the joystick button, I noticed in my original program, as I have the player falling off the screen, as soon as I press the button to try to make him jump, it's always resetting out the jump value. So if I have him jumping up 10 spaces, it won't go up 10. It's resetting that to 0. So something I'm still working on. So I had him just press the button. If you hold the button down, it'll allow him to jump like that. So, and this is actually descending. So this is keeping track of his velocity, or basically his gravity. So if he's jumping off of something, he should fall back down, as you've seen him do earlier. And this is actually another delay. More delays, score. Won't go over all this, but this is clearing the player, making the player. We'll skip a lot of this. This is setting up those numbers, controlling the numbers to the screen. This is how you print data on the screen. Okay, so this one is reading the joystick positions. So what this is actually doing here is just drawing on the player on the first time on the screen. Because later I'm going to animate the player and I want to keep track of where he is, so I always want to update that area and make the player. I did show you that earlier, but I didn't explain it. This is going to keep him updated so I can always see the player on the screen. And that's the high and the low byte of creating that. This is one I've implemented recently. This is actually if you press the button on the joystick, the man jumps up and down. This is the up and down jumping of the man, and here's how this was actually figured out or implemented, still being worked on. First of all, I didn't have this originally implemented, but I added this later, where if you're checking for a collision, if he's reached a collision, then you want to go to a label I called here, which is called PMG call, which basically what this does is it clears the collision. So if you don't clear the collision, then he's going to be able to jump through objects. So something I'm still trying to perfect. This is the one I was explaining earlier. So if he's jumping up 20 locations, so this is going to keep track of 20 in jump range. And if he reaches 20, BCS, remember, is branch carry set. So if the branch carry is set and it's 20 or greater, then you want to jump out of this program basically and jump out so it doesn't do the jump. So if you're jumping up 20, you don't want him to keep going all the way up the screen and off the screen. You want to stop him. So I set his location as high as he can jump is 20 at a time. And this is actually incrementing the jump range. So here's how this is being controlled here. You increment the variable, and then you just basically keep track of the comparison of the numbers that's going on in that variable. So this is all the jumping implementation and the drawing of the character as he's jumping. And here's what I was showing you earlier. So if he jumps out of the loop, and you've already got him jumped up 20 locations, you're going to leave that at 20 until the velocity, the one I showed you earlier, the descend, starts decreasing the value again. I said I probably won't try to go too further because I know people are just not going to follow this very well. And this is just zeroing out the location here of the jump. Here's how you clear player missile graphics collisions. in assembly, you just set 0 to all these positions here. I think it's 53, 252, 53, 54, 55 if I'm not mistaken, or 260, 261, 262, so on. You set those to 0 here, and that will prevent any more collisions from happening. And the collision's just when you're running into an object, basically. Or jumping into one. Here's the decrement of the fall. So if he's falling here, if the descent is actually, if you press the button and you let go, he's going to begin falling. And this is keeping track of where jump range was when you previously pressed the button to make him jump up. So I got this set up right now, so if you just basically press the button, he jumps up, and if you let go of the button, he falls. But the problem is if you hold the button down, it'll look like he's floating in the air, so I need to still work on that. And this is actually keeping track of him as he's falling. Draws him into just drawing the player high and low bite. And it just jumps out of the loop here. Here's the joystick. You might find this interesting. If you want to initialize a joystick into assembly and start doing stuff with it, you would load the accumulator with stick, and you can AND the values, so you can compare them. It's easier just to AND them, and it's a little bit faster if you get the bits. And remember, when you're seeing an AND 1, for example, if you look here back on the graph here to kind of, let me go back to this one. This one's not going to come in very good. So this one right here, you see the number 1 here, that's being ANDed. So if that bit is on, then that's going to mean, in this case when you're using stick, if the bit 1 is on for the stick value, then that means you're pressing the down key. And this stick is the 6, I think it's the 632 that I showed in my other video for the basic one. And if AND 2, so if bit 2 is on, and the same thing in the graph location, then it's going to mean it's the down you pressed. And it goes on to bit 4, and it goes bit 4 and bit 8. And then you just set, you can make these call it anything. The labels, you can name them anything you want. I just call this one left. You would just jump to the left or right, or whichever one you would call it. Here's the fire button. So 644. If the branch is 0, that's what BEQ means. Branch equal. Branch is equal. Yeah, it's abbreviation B. So branch is equal. And I just set a label called PLY jump or player jump. And this is going to allow the jumping to happen. So if you're pressing that button down, it's going to allow him to jump up. I just see this video is like almost an hour. Wow. Okay, so this is actually the up movement. This is if you're pressing the joystick up. This one just moves the joystick up and the high and the low bite. This is down. So if you're pressing the joystick down, it's going to keep track of the down movement. Here's the left I showed you earlier, and this is the label for it. This is actually something I'm still implementing. Right now I have it. If you go to the left, if you're pushing the joystick, oops, I just slipped on it. If you're pushing the joystick over to the left here, it's going to be checking some things in this program. I have it checking to see if you're pressing it to the left, you want to go to this, excuse me, if you're not, what this means is saying, if you see 644 branches equal means it's being pressed, so 644, I'll say, so if you didn't press it, I think this one's saying to draw the left player, to move him. I think I know why this one isn't working now, but anyway. What I have it doing is if you push him over to the left here, it's going to allow you to jump. Normally if you push it to the left, they'll just move to the left. But in this case, if you're pressing the fire, I know it is now, if you're pressing the fire button down and you're moving him to the left, then it's going to allow him to jump, which I have right here. So it's basically going to fall right into this. If you're not pressing the button, it's going to skip out and just move him to the left. So if you're just moving it and not pressing the button, he's going to be to the left. And these again are the player missile collisions, how you check them. And there's some pretty complicated stuff, but think about all those Atari 2600 games on the internet, like I don't know, Raiders of the Lost Ark, Pitfall, and Berserk, Asteroids, Missile Command. They were all created in assembly, just like this. So somebody really had to sit down and figure out how to get that stuff working. So, I mean, if you're interested in designing your own Atari 2600 games, check out assembly because you're not too far away. One of my main missions eventually, I don't know how soon I'm going to accomplish this, is to start creating full screen scrolling, which is known as fine scrolling in assembly. So if I have my player moving up like that, it'll scroll the screen with him. And that's not easily done in the Atari computer. You basically have to manipulate The display list interrupts, and you also have to control the VBI within those, so it's probably too complicated to explain in this one, but I'm gonna do it. So this is just drawing to the right, so this is just moving him to the right, doing the same thing. If you're pressing the button down, then he's going to jump. If you're not pressing the button, you're moving right, he's going to move to the right. And of course, just drawing the character. I can show you this one too. Let me see if I even need to explain this one. X location. Oh no, this is just it kind of explains it. So if you're moving him to the right, I set up a variable here called X lock, which is the player's X position where he's moving at, and just store it into the 53248, which is what this number stands for, and allows him to move left and right or whatever. And then here we're just checking for the collision to see if you ran into anything, and this is actually comparing it to see if you've reached 210. So in other words, if you come all the way over here on the screen at location 210 or greater, branch carry set, then it's going to go to the next room, and I just redraw a new room. So if he goes off the screen, it's going to draw room 32, and I just name them. This one will be 31 because this one's the 31, 32, 33, so on as you keep moving up. And if you have 8x8, you would just add with carry 8 to get to the screen above it. When I had that Dead Man game years ago, which I still wish I had it, I think it had probably a total, if I had to guess, let's see, 8, probably about 60 different screens. And this is how I did it. I had to implement which location and which screen he was in and what was going on in the screens. By the way, that thing took me a year to develop. That thing was not easy. That's when I was barely learning assembly too. So here's the collisions. Here's how you clear them out and everything. I don't have this one working right now, but this number here, 53770, is a random number generator. I just was using this originally to see if my collisions were working and changing the screen different colors based on the timer in that random. And this is just build more players. Let's see, get down here. Try to speed this up, not make this thing freak an hour. Build player, get bytes. This is build 2. Build player 3. These are just drawing the characters on the screen when it's first being initialized. That's what I wanted to show you earlier. This is how you set up a graphics mode. If you look at this code carefully, this will allow you to actually set up a graphics mode once you use the load accumulator with the graphic number. So if you want to use graphics 0, use load accumulator 1, you use JSR GRAFIC, or to whatever you call the label. And you can set up your own graphics mode that way. This is position, but I don't use this one. This is how you plot and draw to in assembly. This one's just called plot. This one's the draw to. It continues over from the plot. Here's the locate command. I don't use it. It does work, but I use my own collision detection. Well, I might try to start using this for some better collision detection. So if you look at my other video where it shows the locate X, Y, C for the color, this is how you would do it in assembly, and you're basically using these let's see what this is doing. Get record command byte. I didn't write this code. This was just found in a book. But you can use these and implement these down in here. I'll show you a little bit later. Here's one right here, actually. I probably skipped the color one down here, but this is probably a good example. So here's how you set up a color in assembly. You would set up the color loop or the subroutine in just JSR color. Then you have to set up these values for load the accumulator with 0, and load the X register with 0. Load the Y register with draw 4. So what this is actually doing is it's drawing my ladders on the screen. No, I'm sorry, this is the floors. So the floors, as they come across here, it's going to keep track of the X position, which starts over here. It's going to try to find out how far down did the Y position go. That's what this is doing. It's just drawing in a loop, and it's incrementing through my floor, and I'm comparing it until it reaches the bottom. And then that means it's drawing all the levels. This one's like 54 minutes. Wow. If my TV didn't shut up, I might have saved some time. But let's see, this is just more drawing, color. Here's how you set up and initialize a character. I think this is the character set. Let me double check. Little high point, store values and pointers. I think this is the character set initialization assembly. Yeah, this is too complicated to explain all this, but this is just basically shifting, moving your character set so you can put it in a new place to redefine it and change the characters to what you want them to look like. And here's how you actually change them. Setting up the RAM for the character, for the new character, set up the high and the low bytes. This is actually initializing the number of characters I have on the screen, so they're all 8 by 8. So if you divide this by 8, that'll tell you actually how many characters I've initialized for this. Would that be 6? So I have 6 characters initialized. Okay, so this draws the character on the screen. This is just getting the location, the high and the low by the address where you moved it to, and just start putting in your new characters. We're almost done with this one, so I think I'm gonna hit an hour on this one. Okay, so these are what I was showing you earlier, how you can set up your own variables, and you can set up your own, I can't think of what this is, DS stands for, but you can set up your own variables and your own little bytes and your S bytes and all that you're going to use in your program. So in this example, this one is being set up for my display list interrupt I showed you earlier, for my vertical blanks. This is the draw floor. This is the up down. I showed you that one. I don't think that one's even being used yet. These are the player. So these are the bytes. If you see these bytes 24, 24, 16, that's what I was showing you earlier on this graph paper when I showed you the numbers over to the side here. That's all these are. These are just setting up the values that you calculate them. And there goes my camera again. I hope this thing wasn't out for a while. It was kind of miserable to watch this one. Oh boy, come on, it's only got an hour to go here. There it goes. Okay, so these are just initializing the player. These are some animation I'm getting ready to work on here. Let's see. Let's straighten this thing back up again. It's almost near the end anyway. These are some new walls I added in for my own players. And also when you set up a character, you also want to use 000 after it to make sure it's not leaving any leftover characters on the screen. So I just cut it out at the end there. And this is setting up the table. I think this is for my character set or something. Yeah, these are actually my individual redefined characters going through here, being changed. So it could be like the wall, the ladder, and whatever else I changed on the screen. I think the water was one. Here's how I've actually drawn the maze. Before I draw it though, you notice I had the score, so basically I'm setting a line here, and actually, you know, I originally used it this way, but then I stuck it down in here. So this is going to draw my entire screens. So you use S byte whenever you use them. When you use these kind of special characters, I think you always use S byte. Byte is for numbers, and S byte is for the regular characters. And this is just drawing all the, this is the levels and everything, and this is the water down here. So that's basically it. Down here at the bottom, this is the display list interrupt, and how you, if you look at my display list video, you'll see me explain these 112, 112, these numbers. So that's basically all this is doing, setting it up. And let's run it one more time. You gotta be clear after all that explanation, huh? It's already in memory, so just go right to it. And we're instantly running the program again. And jumping around and having some fun here. So later on I'm going to have it so you're going to have collision. If he runs into the ball, it'll knock him down or do some funny stuff like that. And I'm going to have him landing on the levels, even though right now it doesn't want to work. I had it earlier where he landed and he stopped on the wall if he pressed it, but now he just goes right through it. So go over here, go to new screen. Something is wrong with the graphics on this one. I need to fix that little thing going across the screen there. So you notice the screen changed when I went over here. This is the in room 32, and this is in room 31. This back here be in room 30, which I'm sure does not exist. Yeah, there's nothing on this screen. I haven't designed it yet. So what's over here? Let's see. Kind of like the first one. These are actually changing the screens as I'm going through them. You know, you can't tell, because see now I'm at a 0 again now. There's nothing there. I haven't drawn that screen yet, so I only have a few screens in it. And that's basically what it does. So, wow, 59 minutes. Look at that one, almost an hour. So anyways, if you're interested, go ahead and subscribe to my channel. I'm going to get more Atari videos out there. I don't know if I'll be able to break down this assembly stuff. This can be pretty long and confusing for people who don't know it. I just wanted to kind of give you an idea of how I built my programming, what I'm kind of up to. Guys, have a great day.